Hello, it's Artur from Artistry of Code podcast. Welcome to the 9th episode. This time it's about challenges of asynchronous communication. Choosing the right method of communication between your services in your application is a very important decision. In order to make it easier for you, in this episode we have brought to the conversation three main patterns of asynchronous communication and a set of aspects that should be considered when picking the right one for your use case. We also shared our experiences on how to integrate asynchronous communication into an existing application and what might be the possible problems doing so. Are you ready? Here we go.
Welcome to the Artistry of Code podcast, where we, together with our guests, are seeking ways of doing things right and having fun with it.
Software, architecture, soft skills, teamwork, and other crazy buzzwords.
Are you ready? Let's bring more value to the business.
Hello everyone and welcome to the next episode of the Artistry of Code podcast. This is the special episode because this is the very first one which we are trying to record with the video. We are really curious about the outcome, but maybe you will see or you will not see that result of this recording. Before we start, as usual, we will quickly talk about the last 2 weeks on our site. And I would like Grzegorz to start this part.
Yeah, sure. So yeah, my last 2 weeks. I actually got COVID for the very first time. Since the pandemic started, that was the first time I got it, and I was really devastated. I really had to skip any sort of like working activities, decision making, stuff like that. So technically I didn't progress too much when it comes to either work or even any sort of like self-development. My voice got killed very, very fast. So if you were listening to the last snippet, you can hear me already not being fully recovered. But yeah, I couldn't delay that snippet recording anymore. So my last 2 weeks were all about COVID, all about regaining my voice. And I'm really happy that everything is already behind me, as I can also start getting back to sports, because I was also not able to do any sort of exercises with that. So yeah, hopefully guys, you were better throughout that time.
I was a bit better in terms of the wellness, let's say. In last 2 weeks I had a lot of challenges on the construction site, as always. And I keep learning that taking new fancy stuff is not always that easy. As I realized that I'm the first person getting the system, the HVAC with the heat pump from Samsung installed in Poland, which is obviously getting complicated. But let's hope it will get okay soon. But on top of that, I am taking part of a lot of the interviews recently, and the fun part is that there is the never-ending discussion if we should do the live coding to some degree on these interviews or not. I'm really curious about your experience here, but this may be the topic for another episode, because it's really not easy to answer in the end. Yeah, but yeah, that's mostly it for my last 2 weeks. Artur, what about you?
Yeah, my 2 weeks are quite well. I didn't have any issue with my health, fortunately. From the construction side, recently I learned that estimation of the cash spent on of the finalizing the house works out just like the estimation of tickets in our daily work. So you always need to like multiply it by 2, and then you have the final result. That's pretty much what happened to me in my on my construction site. So I already updated my budget, and so hopefully it will be possible to deliver. On the daily basis, I now try to relive the yesterday's evening. I haven't said it yet on the podcast, but I'm a big fan of Real Madrid club, the football. Yeah, and they yesterday got advanced to the final of Champions League, and I was very satisfied with this fact because they were rather said to not to be the expected winner of that match. So I'm pretty excited about it, and yeah, this gives me the energy to go on. So I think that with this said, we can proceed to our topic, which is no less exciting. Marek, would you introduce us?
Yeah. So today we gathered here to talk about the challenges in the asynchronous communication in the applications, services, and systems in general. First, we have to say that we will try to avoid going into any language specifics, but we want to discuss more in the big picture how the asynchronous communication affects the business and why it's important to make this decision to go asynchronous consciously. Yeah, and disclaimer: we will not talk about the difference about the await in the code or any other way of using the asynchronous code in the languages, but we will talk only quotation marks about the communication done asynchronously. To start with, we would need to think about making the decision between the synchronous and asynchronous communication, because I strongly believe that this is something which has to be done at the very beginning of designing either the whole system or the next building block. Because it affects the business, as already mentioned, and sometimes business will not accept some asynchronous results, let's say. What do you think, guys?
Yeah, I feel it's also very important because it affects how the end user will see its actions in the application. If you're creating a mobile app, for example, and the process that you are triggering is taking a very long time, it might be a bad decision to make it synchronously and make the user wait for the result. On the other hand, this can be also misleading if you will receive a notification that okay, what you wanted to do is already done, but in fact, in the background, some process is processing it longer and it's not yet finished. So yeah, the challenge is big, and for me, the main thing from this decision is what is a crucial part of the process that needs to be, like confirmed to have been done when the user has a feedback from application. So what is a side effect? What is the main effect of this action?
For me, when it comes to deciding between synchronous and asynchronous communication, I usually tend to look on how the business operates. So if we are building up a system, and this system is reflecting the business reality, then we can somehow try to tap into the life cycle of how the things work. So One of the ready-to-use tools which I frequently utilize is asking those like two powerful questions. So the first question when I'm deciding about synchronous asynchronous is whether this action should be done right now as part of handling the current request, so to speak, or can it be done later, right? So this already tells me, should this be done immediately, so in a synchronous manner, or in an asynchronous manner? But when it comes to the asynchronous, when it comes to the later, the business kicks in. If 15 minutes is okay, if 5 minutes is okay, if 10 minutes is okay for the later part, then we might, when we ask that question to the business, they may recognize, okay, but when we're thinking about this, I think 15 minutes is not enough, right? So then again, this gives us another branch of possibilities, because we either can handle like timeouts for message or asynchronous communication processing, stuff like that. So I guess we'll be going into the details later on, but right now I think what's really relevant in terms of deciding between synchronous and asynchronous is how the business operates, whether this should be done now or it might be done later, and how much later is acceptable for the business, right? So at the end of the day, this boils to the business, and also what Artur you've mentioned. It has a consequence for the end user apps, right? And sometimes we don't see this, but we should also consider, right? If we make up a decision that something is going to be asynchronous, that probably will leak somewhere else, and if it's going to be acceptable somewhere else.
From my experience, that's the point which makes really valuable to have the UX people on the architecture design meetings, which is not that obvious when we think about who should we invite. But yeah, the UX people can often give really valuable input to this kind of decisions.
I also wanted to mention that not only on the front end we will see the effect of the decision that we made, but also in the back end, especially when we are using asynchronous communication. It's sometimes like make the clear way for the entry point. So entry point is behaving quickly responding to the end user. But if the process inside takes some time, then we can have some bottlenecks somewhere in the some other place of the application that we need to then handle with care. So in some, let's say, the worst situation possible, you can even lost a lot of messages because of the crash of a service that handles the asynchronous communication. And we also need to take that into consideration even when deciding, because when you go synchronous, then the rest of the system is more or less limited by the possibility of the entry point. Yeah, then the rest is like everything is going smoothly in the same pace as the entry point of the system. While in asynchronous communication, it is a little bit harder to keep the same pace.
Yeah, so what you've just explained, Arthur, is like super relevant, because the two questions which I've mentioned are just a starting point, right? Because at the end of the day, picking the asynchronous communication has a lot of consequences when it comes to like resiliency, rollbacks of unsuccessful processings. That's about eventual consistency stuff like that. So we were just mentioning this. We're not going to go too much into the details here today, as we're pretty much time constrained. But the thing here, guys, and our listeners, is that asynchronous is probably the harder way. It's the mostly scalable way, I would say, but it has consequences which have to be considered, and sometimes those consequences may form a non-functional requirement or a constraint, which is going to lead anyhow to the synchronous communication style, right? Because that might be, for an instance, achievable within the quarter. This is one of the conversations which I'm having right now. Whether we should do this synchronously or asynchronously, the question which follows is whether that's achievable in the current quarter, which, given we are in in the middle of that quarter, right?
Yeah, that's true. And there's a lot of challenges to overcome in asynchronous communication. And sometimes, especially when you are in some startup where delivering a business feature is more important to the company than delivering it in the technical perfect way is more important. So there's a quite high probability that if you will pick the asynchronous communication, you will focus more on the technicals of the solution rather than introducing a value to the business. And this is something that you guys need to take into consideration, like try to calculate it with money in other way.
Yeah, I guess it's just us developers mostly liking to have a fancy system with a fancy pattern, but it's not the best decision making factor, I would say, when it comes to this one. So I guess that with this, I think we can go to the next point, which we have for today, which is a different kind of a challenge. So, given you've decided that between synchronous and asynchronous, given all the constraints which are there at the table, you have to start picking a possible technical solution, right? So, picking the right system for asynchronous communication is the next challenge. And I know, Arthur, that you wanted to bring us a nice list over here.
Yes, I have the list, but it's rather short. There are only three positions. So first of them is a mechanism of queue. And the example is RabbitMQ. Second one is the event stream, and the example is Kafka. And the third one is the PubSub, where one entity publish some event and other entities can subscribe to that event. And depending on our use case, business requirements, we have those three options to pick from. And for most of the cases, I feel like um, the queue will be the first pick. But in my opinion, when you have the requirement of keeping events or messages delivered in the order that they were published, and it's really really important for the business, because otherwise it will no the system might end up in some unexpected state. Then you should take a look at event stream, because it's focused on delivering events in the particular order, uh, which may not be achievable like in 100% certainty by the queue system, because of some concurrency, and it's asynchronous, so there's always challenges.
And the PubSub won't give you any order, in any way. Yeah, that's
Yeah,
true.
and won't give you retention, most probably.
Yeah, that's I was just going to say that the nice thing about the event stream, or even with the queuing systems, is that you can start working on the system, release some parts on the publishing side, and they can publish, I don't know, millions of messages before the consumers will be released. But with the proper setup, everything will work smoothly, because the messages will be just waiting in the queues or in the stream. While with the PubSub, exactly, you don't have any retention, at least out of the box. And I would, from my experience, I would use simple pub subs like Redis, just for the stuff which is completely not business critical. Yes, so like simple notifications, or I don't know. It always depends, because notifications can be critical to the business. Yeah?
So I'm looking for those questions which our listeners can make use of in order to make up that decision, right? So you've just nicely covered the retency of those messages. So I recall the solutions like the Azure Event Hub keeping up the record for like 7 days. So you could replay all the events from a week ago up till now in order to build up the state of the system. Then we have the queuing, so the messages are there when up to the point where they are consumed from the queue and it pops up. If you're not there at the table when people are talking, then you don't know nothing. That's pretty much the consequence. So I think the question which emerges from here is that whether I will be needing that message like later on. Will I have to replay that information? Do I need to have the access to that information? Because depending on the necessities here, the requirements from the business, one of those options may make more or less sense. Do you guys think we have any other questions which our users can, our listeners can utilize in order to make a good decision? So the retency question is already there, right? What could be another interesting question?
Maybe the performance, because depending on your use case, not all solutions will perform fast enough. And I am thinking about partitioning, especially. Yeah? So yes, these solutions have some limitations. For example, something that was very surprising for me was that if you want partition event stream in Kafka, then you're able to connect with only one consumer per consumer group. This is something totally different than in RabbitMQ, where you can scale horizontally the consumption, just add another instance and it will work out of the box. Yeah, so picking the right tool, also think about partitioning messages, ensure that that messages that needs to be in order will be in the same partition. It's something also to take into consideration.
Yeah, just to elaborate about that partitioning, because this might not be initially easily understandable for everybody. So when we think about the solutions like Kafka or Azure Event Hub, the events upon ingestion are getting segregated into different partitions. So there's a partitioning function which is placing them into partitions. So for instance, in the Azure Event Hub, you are going to declare how many partitions you are going to have. And this has a consequence that for your scalability, because later on you'll be able to run concurrently the same number of consumers of that event stream as the number of the partitions you have. So doing that decision correctly in the very beginning has a high impact for the scalability, which leads to the next question, which can be utilized. What kind of scalability I do expect? Because like Artur, you've rightfully mentioned, with the PubSub solution or the queuing, we're pretty much unconstrained. We can go really wild when it comes to the amount of consumers for that information, but with the partitioning of data, is a trait of the event stream systems, at least for Kafka and for Event Hub, which really has to be regarded. Because later on, you really get very surprised by the fact that you can have only one single active consumer on a partition. This doesn't mean that you can't have 10 of them. You can, but only one of them can be actively consuming at a time. We will refer you to the docs of the Microsoft where this is explained more in depth. But yeah, the question of scalability and by consequence the question of performance is super relevant here. Yeah.
This leads me, the mentioning Microsoft here leads me to another question, maybe which our listeners may not really have, but it's worth to ask these questions always. If we are okay with the vendor locking, or we have to like be completely unlocked for some business reasons, yeah, because there are great solutions for asynchronous communication on basically every platform, which are native to those platforms, and they are usually fairly easy to set up because that's their selling point. Um, but on the other side, if you are not okay to get into vendor lock because of the business requirements, you have to choose more complexity, but get the freedom of choosing whatever cloud or the hosting way which you want.
Yeah, with this one vendor lock, what brought to my mind is that not always you also have the possibility to run the local instance on your computer, or if you want to make an integration testing, there's not always, for example, a Docker image of the service that you use as the provider of async communication. So, for example, we were not able to test IoT Hub without spawning in the cloud the instance for local testing. And sometimes, if making your solution testable and covered on multiple levels, this might be a very important input to decide. Yeah, and to decide not only between the implementations of this asynchronous system, like picking between Kafka versus Event Hub, but also if I will be able to deliver a asynchronous communication system which is testable, which I can test and prove every time that it works as expected.
Yeah, that was a great point, Arthur. I really like that one. I think I would like to get closure on that vendor lock thing. With one point, you might be coming across those advertisements that a certain solution has a Kafka compatible endpoint. It's not against Azure Event Hub. I really like that solution. They are also exposing, like a Kafka compatible endpoint, so you could consume it like it would be a Kafka. But usually there are a lot of asterisks saying that this doesn't work or that doesn't work or that doesn't work. So sometimes you can have those technical discussions like, okay, we're going to use EvenHub, but it's not going to be a vendor lock because we're going to use the Kafka compatible endpoints. And then those asterisks start activate a couple of weeks before the market release. So you probably don't want to be misled by that at some point. If you're planning to use Kafka, probably it's good to use Kafka and not a Kafka compatible endpoint instead. I think also there's one additional question which is relevant for like architectural decision making, and that's quotas, throttlings, and pricing. Right. So when I'm thinking of Redis and pops up, spinning up Redis instances is pretty much like simple, I would say. Most of the services out there provide this service in the cloud. The same goes for RabbitMQ and for Event Hub. So given we're in the cloud world and we don't want to have on-prem solutions, we would like to just buy them off the shelf, then we are quickly hitting some limitations. Like you can send that many thousands of messages per day. You can publish that many messages per second, and it's a hard limit. and this in consequence also leads to the pricing, right? So when we are deciding which of the tools we would like to use, sometimes the quotas, throttlings, and pricing also have an effect over here, right? So it's not only about like picking whether I need that FIFO experience, do I need that latency of the data, but also that pricing factor is super relevant, especially now. I saw it in a lot of places where companies started to downscale the resources over the cloud to lower degrees in order to save some money due to the pandemic, for instance, right? So the quotas, throttlings, and pricing aspects are also something that should be considered and at least compared. This might not be the main driving factor, but I also find this interesting to take a close look at those, because later on in the development phase that they might also manifest themselves, and we had this in life. We really had this in life, that we were getting a off the shelf solution, and at some point the messages stop flowing, like late evening, and you know what happens. The keyword here is on call. So
Yeah, I feel like those asynchronous fancy solutions are quite expensive. Not only when bought as a service, but also when you need to have it on-prem. I remember that maybe now it's not that problem, but few years ago, a few companies before, I remember that it was very difficult to find admins, system admins that were able to support, start the RabbitMQ, support it, understand what is going on, know how to configure it correctly for our use case. So it was very expensive, on not only in terms of the cash, but also on the time required to hire right people. So it's another challenge for the whole organization. Okay, but we also need to take this asynchronous communication when it comes to the application lifecycle. It's not only on the administration level, very complex problem, but also when we need to prepare the application to handle this communication correctly. And we also need to prepare the startup, the teardown of application to ensure that nothing is lost. You guys maybe have some um, maybe have some experience how to do it.
shareable memories, Marek.
I think we have
It's
some.
not that you did something wrong that I called you out. It's just
No, we have some we have some shared memories on this, because
collective.
at the time when we were working together, we were struggling a lot with that. But I would like to share the challenge which we are now facing, and we are solving that right now, which is about dealing with the shutdown of the application against finishing the processing within the process itself, which is maybe not crazy hard to tackle, but it has to be considered when designing, because we can go that simple way that we will not shut down the application cleanly, and everything will stop processing because before Kubernetes will kill it, but it can be done much nicer with the tracking of the processing process, and then shutting down the application cleanly with ensured processing being complete.
Yeah, so the thing which we are kind of referring here to is, just to rephrase this a little bit for our listeners, is that you frequently can find yourself later on at high load. specifically high load after some time, within the situation that your application is processing hundreds of thousands of messages per second, and it might be the case that your process will be scheduled for a shutdown, and then there's a lot of in-flight work which should be completed successfully, or at least in a graceful manner, which will allow us to not ruin the whole process, right? So yeah, and that tends to be pretty challenging. And the problem, which I would like to emphasize here, and I think, guys, you will totally agree with me, this is not something that we are thinking of in the very first time when we are starting an application, right? So everybody raises a hand who always, while starting a new project and consuming the messages from a queue, immediately includes necessary control statements for knocking a message upon an error and deciding whether that's a retryable thing or it's not a retryable thing. Those things tend to come in late. That's, I guess, one of the biggest problems when it comes to coding asynchronous communication, is that we on the local workstation everything works fine most of the time. But at scale, those side effects start to manifest themselves.
Yeah, after this, our shared experience with asynchronous communication, right now I tend to put my focus on this part, and I have quite a simple quite a simple strategy there. I mean, if first of all, I also try to add the validation, and if something is not passing the validation, then it should be put to some kind of dead letter queue. So let's name it the shelf that you can then put it back to the queue after fixing some code. So something that does not pass validation goes to the dead letter queue. If
So
something
just
is yeah,
let's stop here for a moment now, because this might get very interesting.
why?
Now, if you validate the input, right, uh, and you talked about the queues, now what would you do in a pub sub and on an event stream?
The PubSub is a jungle. If it does not pass the validation, it just is redirected to dev null. In the event stream, I saw the implementation of the event stream with its own implementation of the dead letter queue. So it was like dead letter event stream,
Okay.
which can be retried. Yeah, all the messages that were there can be retried if it's necessary, and it's not a bad thing, I feel. But but if you create that letter event stream, the crucial thing is to also make a consumer for it.
Like
And
with the dead
this
letter
this is
queues.
something this is something I haven't seen yet. So I have seen the storing things on the that letter event stream, but not consuming it yet. Maybe it
This
will
might be the
happen.
case that issuing a log statement with an error message would do equally the same and
Yeah,
not
yeah.
cost infrastructure.
Yeah, but also what I see as a retriable error is always a transient error. Some problems with storing process data to the database, or some other problems that can be caused by let's say external factors, and not a bug in the implementation. So it also always should be retried with some wise strategy when to do it. And this is actually the end of my strategy. I mean, if there's also an error in code, making the processing not passing, I think that dead letter queue is the only solution then, because otherwise, if you will on the queue, we will send a nag. On the event stream, we will also not confirm the message processing. We will be stuck at that point. Without a change in the code, the application will not be able to consume the rest of the data that is stored in that is waiting to be processed. So it's a very dangerous situation that whole application can stop at some point.
Yeah, it's dangerous, but I would say it can depends on the circumstances, but it can be also beneficial, because when you stopped at some weird point, you don't get deeper into this hole. Yeah? So it's dangerous. Yeah, it can provide to some outage, but in the end, it may even save us from getting into even worse position. But while we are talking about dead letter queues, it brings me to the challenge which directly connects to that, which is the proper monitoring of the system. Let's say either queue or the event stream. While PubSub can be difficult to monitor, it can be just probably monitored. Is it working or not? But yeah, on DLQ it's great. But when we have the DLQ set up, I found it's really critical to have like a proper alerting on that, with threshold being set to 1, basically. So if anything's end up in the DLQ, we should immediately take some action, because it most likely means that there is something really broken in the system.
Yeah, but what you said at the very beginning is also very important. Yeah, you said that sometimes we want the system to stop at some point, and that's true. Because what I said, I was having in my head that we don't want the system to stop and be in that stopped stuck phase without a notice, like us noticing the problem. But if we will notice the problem, then it's fine to stop and crash at some point. And uh, it just like a flashback from from the time we were working together. And Grzegorz, you always said that it's very important for you for our application to break fast. So it's better to crash the application and that we could see the alert from Kubernetes, for example, that something is going on, rather than let it stay in this error state and like putting values back on the queue without monitoring that you, Marek, mentioned. So yeah, this is something that needs a complex solution to make it visible that the problem is there.
Yeah, the point about monitoring is actually deserving also to be brought back in terms of the questions to ask yourself when it comes to picking the right system, right? So it's about the traceability, it's about the visibility and monitoring capabilities. I didn't look at the Grafana dashboards for quite the time now, but I recall that we had different dashboards created for different parts of the system, visualizing the queues and having those alerts set up just to know that either things are piling up in front of some consumers after a deployment or due to a memory leak or something. So yeah, monitoring queues definitely something to do along with other resources, right? So sometimes you can exhaust the amount of connections on your SaaS instance of the service, and this is tending to get really tricky. I would like to get closure because we started to talk about handling the errors there. So just to have the closure on the life cycle. So I think the most critical part here, and I guess, guys, you can confirm as well or add to that, is that whenever we're building an application, we really have to think about that aspect specifically when we're running with Kubernetes or any sort of orchestrator in case of which we don't control the lifecycle, is that at some point my app is going to be shut down. You can assume, like in Heroku, with the 12-factor application approach, they tend to tell you that your app is going to be killed once a day, because it's just going to be killed to prevent memory leaks on the underlying infrastructure. So you can build up your application with the rule that my app is going to get closed at least once per day. And frequently, my app has only 30 seconds by default to get the stuff done before it gets a SIG kill, and it then it's no longer able to do anything afterwards, right? So the fact that your app is getting closed and you have 30 seconds to finish everything which you've started follows with making up, like decisions. Okay, if I'm having a shutdown signal, what I should do with the messages which I'm processing for somebody asynchronously, they need to have the feedback somehow, right? So either the message has to be put back where it was, or I'm not going to move the cursor in the stream. It all depends. You just need to be aware of that you have a limited amount of time to do things cleanly, right?
Yeah, I remember that we spent a lot of time figuring it out how to do it.
So
Yeah,
that's a
now
valuable piece of information. We
I
really
can
spent a lot of hours into on that.
I can bring you a important tip. First, close the input to your application. It's either consumer on the or the server HTTP. So you will not have more work to finish up, during the graceful shutdown process.
Yeah, stop accepting requests, whatever they are. Stop accepting requests. That's the first point to do. Like, I guess you can figure out the rest now, because this can lead exactly to the second part, which is handling the errors in the messages processing, right? So just to rephrase what we have so far, we've talked about the validation, right? So we either are going to process that message or not, and then we can go into the dead lettering discussion, which we had so far. What else we can say or recommend on handling errors during message processing? Obviously, like throwing a good old error log entry with with enough details is obviously welcomed, but just remember to anonymize the passwords in the logs. Don't store passwords and user credentials there. Specifically, do not log the connection strings to the RabbitMQ instance on which the error appeared.
I would say also do not send the passwords in the message between services. It's also not the best. Or maybe if they are encrypted, that's fine. But what I wanted to say is you need to keep the transaction for the data that you process. So if you started processing the event and for some reason it failed, you should revert or be able to revert all the changes or make the event processing. How was it
The
I
hard
didn't
word idempotent.
idempotent, yeah.
Idempotent.
So you can consume it once again and without making a disturbance in force, apply those changes once again. So it's either rollback or idempotent processing.
Yeah, the idempotency is probably the best, but it's often crazy hard to achieve in some cases. Um, but while we are talking about the questions which we should ask ourselves when thinking about the asynchronous communication, another one comes to my mind, which is how will I know if the errored message can/should be reprocessed? Yeah, so with the validation, it's fairly easy. Yeah, we cannot process this message. Let's make it go to the DLQ. But it's really worth to consider it upfront in what situations we want the message to be requeued. Maybe we just had an issue with the database or something, but maybe in some cases we cannot process this at all because of some business requirements, even if the validation of the message itself is correct. Yeah. So I think this is really worth to consider when designing the solution and to determine the paths when it should be reprocessed or when it should go directly to the dead letter queue or dead letter stream.
Yeah, and then I'm trying to recall the solution with the code which we had for these kind of situations, right? So we had a set of helper functions which were judging if that's a retriable error, for an instance, right? So essentially, when you look in the code, you saw that the message was accepted by the consumer, and there was a try catch block. The try was trying to dispatch this to the application services to deal with the problem, but then again, this might yield an exception, and then this exception has been judged whether that's a retriable thing or not. So within the same function, you saw try to do that if there's an exception, and that's a retriable exception, knock it and requeue it, for an instance, back on the queue. So that's reattempted because that was a transient error. There was a blip on network, or the connection was switching to the database, or stuff like that. But there might be those critical ones where we're going to put them in the dead letter queue or just nag them without requeuing, so effectively discarding.
I remember that when working with Event Hub and as a producer, I remember that Event Hub returned the error which with property of is transient probably or is retriable. So it was very helpful, and you can also integrate it to your system.
And then on the publisher side, right? So that was the case when you're having a service and you're pushing too hard on that service, and that service starts to give you feedback. You should stop. You should lower down the amount of work for me, and then
Hold your horses.
hold your horses. Boolean flag on the returning message.
Sometimes the cloud services will just reply with the error, with the message, "Give me more money," and then I will process. It happens.
I guess I'm not sure if that HTTP return code payment required is used. I always see this on the MDN that it's there, but I'm not sure if somebody effectively uses that payment required
It's $4
HTTP response.
dollar, yeah, dollar sign.
Okay, so when it comes to the error handling, do we have anything more to add? As we are slowly getting close to the end of the episode, so I'm trying to wrap things up for now. I think the one you've Arthur touched the producer side, and what we just said was that sometimes the service to which you're publishing the component gives you feedback that something's wrong, right? So if you have even if you have RabbitMQ, yeah, and you're using confirm channels, that might be the case that the broker will tell you the message which you've published didn't go anywhere. Nobody was listening for this. There was no topic for that, queue for that. I'm not able to do anything more with that. So you, as a publisher here, you also are left with the decision what I'm going to do about this, right? So if I'm putting a bank account transaction this way for any reason, okay, that's a different case if I'm adding a blog post asynchronously, right? So there might be different outcomes, but those errors, they're not going to happen only on the consumer side. They will also happen on the input, right? So it might be the case that you're publishing as part of the serving of a HTTP request. That might be the case. So this might be simple. A 500 probably will do a good job. that really can be the case. But if you do it in a fire and forget manner, then you need to think twice. Because if I'm publishing in a fire and forget, and I just like do the catch block, and I'm not doing anything necessary or required in that catch block, most likely that's going to be an issue, right? If the broker is going to decline or reject that publish. So think about this while publishing, that sometimes the fire and forget might not be the good approach, and you need to think about publishing errors as well. So the keyword to research after this episode, guys, is publishing errors and handling publishing errors when it comes to asynchronous communication.
Yeah, but fire and forget has also its pros, not only cons. It's fast.
Obviously, yeah. Well, it's not blocking the main thread, but then again, the question is, what will you do when things go wrong, right? So, what's the impact there?
Yeah, but
It always depends.
running fast,
Mhm.
if it's running fast, you can sell it. You can sell it. The others will buy it. Of course, it's a joke. Don't
Yeah.
use fire and forget. It's
It's going
make
to be
you trouble.
easier assessed because you guys can probably see our smiles if the video version goes out. So,
Yeah, I would really like to call out to our listeners here to share your experience with the asynchronous communication challenges. What was the maybe weirdest experience which you had? We are more than welcome to share with us in the comments on the platforms, and we will likely discuss maybe that in some next episodes.
Yeah, and we can see that the topic is so wide that we will probably touch some of the problems of asynchronous communication in detail. Yeah, so we have few candidates for another episode, so stay tuned.
and then I guess it's time to say goodbye, guys. Take care.
Bye bye.
Bye-bye.
That's all for today. Thanks for spending your time with us. Visit our page on Facebook and Twitter, leave us a comment under the episode, subscribe to the updates, and share it with others.
We would like to hear your feedback so that we can prepare more interesting content for you to enjoy. Hear you next time!